I have a I have a serious bone to pick with the English language.
Oh, just one.
No,
I
seriously.
feel like I've got a list a mile long.
Think about it. Think about the very first spelling rule we all learned. I before E except after C.
Right. It has that rhythm. It feels true.
It sounds so authoritative, doesn't it? Like it's a law of physics or something.
Yeah.
And then you turn, 8 years old and you have to spell the word science?
SCIENCE.
Yeah.
The rule breaks immediately.
Then right away. And it's not just science. It's weird. It's neighbor, foreign. I actually looked this up. There are more exceptions to that rule than words that follow it.
It's a total mess.
A total myth.
But that's the whole thing about natural language. Linguists call it a historical accident.
An accident.
Yet nobody designed English to be logical. It's just this patchwork of German and French and, I don't know, Viking grunts that just sort of happened.
And okay, that's fine for, ordering coffee or writing a poem. But here's the premise for today's deep dive. And this is the thing that really kept me up last night.
Okay.
If language is this buggy, glitchy, accidental mess, why on earth are we using it as the operating system for our entire legal system?
That is the billion-dollar question, isn't it?
Yeah.
We use these fuzzy words to define everything that matters. Freedom, crime, property.
And today we're looking at a stack of sources that basically just argue, stop doing that, stop building on a swamp. We're exploring what they call the computationalist reconstruction of law.
It's a bit of a mouthful.
I love it.
But the goal is, it's fascinating. It's about moving from that fuzzy natural language to hard formal logic.
We're talking about treating law like actual software, a system that doesn't just interpret rules.
It compiles them.
It compiles them.
Exactly. And our sources today, they're pretty wide-ranging. We've got this really heavy critique of something called paraconsistent logic, which we'll get into.
Wild.
It's wild. Then there are concepts from linguistics, like Montague grammar and Lodgebin, and this final vision of a technocratic constitution that acts more like safety software for a nuclear reactor.
So if you're a programmer, this is going to sound like heaven. If you're a lawyer,
You might want to pour a stiff drink.
or maybe just update your LinkedIn profile. Okay, so let's start with that bug in the system. The source material is surprisingly harsh on just language itself.
It is. It argues language evolved for efficiency and social cohesion, not logical consistency.
Right.
I mean, think about how we talk. We prioritize speed. We use context and tone and, shared experience to fill in all the gaps.
Sure.
If I say the bank is closed, I mean the money place, not the side of the river.
Because, I don't usually deposit my checks into a river.
Right. But that efficiency has a huge cost. It leads to what the source calls diachronic evolution.
That's just a fancy way of saying language drifts, right? The meaning of words changes.
Exactly. Think about the word awesome. It used to mean like terrifying or inducing awe.
Like a bolt of lightning.
Yes. Now it means, I like that burrito. Or the word nice in the 13th century used to mean foolish or ignorant.
Wait, really? Nice meant stupid.
It did. So you see the problem. If you write a law using the word nice in 1750 and someone tries to apply it today,
You have a fundamental compatibility error. The language has updated, but the law hasn't.
the foundation is just unstable. And legal scholars, they try to patch this with ideas like originalism or a living constitution.
But the source says those are just arguments about how to interpret the bugs,
Not how to fix the code.
Right. And speaking of bugs, the sources point out two specific gremlins in the system, polysemy and amphibole.
Mm-hmm.
Polysemy, I get. That's the bank example. One word, lots of meanings.
Simple ambiguity. We deal with it every day.
But amphibole, that one was trickier. I had to read that a couple of times.
Amphibole it's when the ambiguity isn't in the word, it's in the grammar itself, the structure of the sentence.
Okay.
The classic example is that old Groucho Marx joke, I shot an elephant in my pajamas.
Oh, right. So did you shoot him while you were wearing your pajamas?
Or did you shoot an elephant that has somehow gotten into your pajamas?
Right.
Grammatically, English allows for both. The sentence structure itself is ambiguous. Now, in comedy, that's funny. In a legal contract.
It's a complete disaster. It's like that classic example, no vehicles in the park.
Yes.
Does that include a wheelchair, a baby stroller? What about a toy car, a drone?
And that's where the whole system has to fall back on what we call judicial discretion.
Which sounds like a good thing. We want judges to have good judgment.
You'd think so. But the source has a much harsher term for it. It calls it manufacturing truth.
Oof. That's a heavy accusation.
It is. The argument is that if the law itself is that vague, the judge isn't discovering the truth. They're essentially creating it on the spot to fit the situation.
They're patching buggy software while it's still running.
And every time a human applies a patch, they introduce their own biases. That's why sentencing can be so inconsistent. The input is fuzzy, so the output is fuzzy.
Okay, so natural language is a terrible programming language. I'm sold. I get it. But that brings us to the really, really dense part of the source material.
The logic itself.
The logic itself. Because I always assumed, okay, the words are a mess, but the logic underneath it all, that has to be solid.
You would hope.
But the source says, nope. It says the law runs on something called paraconsistent logic. And I had to read the section like 3 times.
It's crucial, though.
Okay, so help me out here. Standard logic, you know, the kind computers use. Math, it hates contradictions, right?
Absolutely.
If A is true, then A can't also be false.
Correct. In classical logic, there's a rule called the principle of explosion.
Principle of explosion. It sounds like something from a bad action movie.
It's much scarier. It says that if you accept a single contradiction as true, if you have P and you also have not P,
And what?
then you can logically prove that anything is true.
Anything.
Anything.
So if I accept that, say, the sky is blue and the sky is not blue are both true at the same time, I can suddenly prove that pigs can fly.
Mathematically, yes. Once you allow a contradiction, the whole system of truth just collapses into noise.
Okay, but the law is full of contradictions. All the time. One statute says protect free speech, another says prevent hate speech. Those two are constantly in conflict.
Constantly. So the legal system can't just explode every time that happens.
Yeah.
So it uses this paraconsistent deontic logic. It's a way to dampen the explosion.
It puts the contradiction in a little quarantine box.
That's a great way to put it. It says, okay, we have a conflict. Let's just isolate it and use discretion to solve it. But our source it destroys this idea. It calls it a magic wand. Pseudo-consistent non-logic.
It was scathing. It said if all you do when you find a contradiction is wave a magic wand and say it's contained, then you don't really have a logic at all.
And this is where it gets really weird. The source walks through this proof to show how absurd it is. It argues that with this kind of logic, you can prove anything by fiat.
Okay, let's walk through that proof because it's nuts. Step 1. If anything is possible, it is possible to find a proof of A.
Right. If the system is paraconsistent, the logical barriers are down. So finding a proof for, say, the moon is made of cheese, it's theoretically possible in that broken system.
Step 2. If it is possible to find the proof must exist.
Which is a kind of modal logic idea that possibility implies existence in some abstract sense.
And step 3, this is the kicker. Since we know the proof exists, we don't actually need to find it. Therefore, A is true. The moon is cheese.
And you can run the exact same proof for not A. The moon is not cheese.
It's just circular insanity. It's saying, because I can imagine a justification, my justification is valid.
Precisely. The source's point isn't that lawyers are actually proving the moon is cheese. It's that structurally, this is how it works. You can derive any conclusion you want if you hold the magic wand.
We have a buggy language and a fake logic system. It's not a great picture, but the source does offer a fix.
This is where we leave the philosophy department and head over to computer science.
We're talking about replacing English with something cleaner. The sources bring up Montague grammar and Lodgebon.
Let's start with Montague grammar. It's from a logician, Richard Montague, who believed there's no real theoretical difference between natural language and formal, programming languages.
That feels like a bold claim after everything we just said.
It is, but his work was about creating a bridge, a system to map English sentences directly onto mathematical logic. Think of it like a translator layer.
Okay, and Lodgebon.
Lodgebon is the next level. It's a constructed language, invented specifically to be logically perfect.
Okay.
In English, a sentence can be interpreted multiple ways. In Lodgebon, every single sentence has exactly one possible interpretation, one parse tree.
One parse tree, so there is zero ambiguity.
Zero. If you say, I shot the elephant in my pajamas in Lodgebon, the grammar itself tells you unambiguously who is wearing the pajamas.
So you can't make the joke.
You cannot make the joke in Lodgebon. Goodbye comedy, hello justice, comma chasing.
So the idea is we write laws in this math language.
That's the vision. And that leads to the concept that, it really blew my mind, the self-executing law.
Because if the law is code, you can run it through a compiler.
Yes. And a compiler checks for errors, before you run the program.
So what happens then? If some politician tries to pass a law that, I don't know, contradicts the Constitution?
Well, in our system now, it's a whole mess. It gets passed, someone sues.
Years later, maybe.
Yeah, years later.
Yeah.
But in this computational system,
What?
it's a syntax error.
I love that. Just error. Justice not found.
It wouldn't compile. The system would just reject it. It would say, this new theorem contradicts the axioms of the kernel. Cannot proceed.
So it stops tyranny before it can even start.
It changes unconstitutional from being, a matter of opinion for 9 judges.
To a mathematical fact.
Yes. The math proves it's invalid. You don't need a judge to interpret it.
Which brings us to this idea of the legal kernel. The source compares the Constitution to the kernel of an operating system.
Right. In high-stakes software, like for NASA or for medical devices, they use something called formal verification. They use these tools like Coke or Isabel Hall.
These are proof assistants.
Exactly. You don't just write code and hope it's right. You mathematically prove it's right. The source says we should do that for the Constitution.
So the Constitution becomes the set of axioms, the fundamental truths.
The hard constraints.
Right.
Thou shalt not violate free speech. That's an axiom. And every new law is a proposed theorem.
And you have to prove that your theorem is consistent with the axioms.
And if you can't prove it, it's not a law. It literally cannot be added to the system.
The source has this amazing analogy for this with small modular reactors, SMRs. This part really made it click for me.
This is that technocratic constitution idea. So imagine a city in a giant sealed greenhouse powered by these little nuclear reactors.
Okay, so we're in a dome city. Survival is all about managing the system perfectly.
High stakes. Now, in this city, the legal code and the physical control code for the city's infrastructure are the same system. They're integrated. And let's say a politician running on fiscal responsibility tries to pass a law. And that law is effectively a command to the system to cut power to life support by 20%.
Very bad idea.
A catastrophic idea. In our world, they could pass that law. People would suffer, maybe die, and then we'd vote the politician out.
Too little, too late.
Way too late. But in this city, the system has a safety property. It knows that life support below 100% equals catastrophic failure.
So the politician hits enter to pass their law.
And the system just rejects it. Not because a judge said no, it rejects it because it violates the physics kernel of the reactor.
It's the ultimate computer says no.
It's auto-invalidation.
Yeah.
The law is invalid because it leads to a mathematically defined disaster.
This is a huge philosophical shift, though, isn't it? The source talks about moving from legal positivism to a model of discovery.
Yes, and this is crucial. Legal positivism is basically the idea that law is law because we said so. It's arbitrary. The speed limit is 55 because the sign says 55.
Because I said so, jurisprudence.
Exactly. But in this computational model, law becomes more like physics. You don't invent gravity, you discover it. The source mentions the physicist David Deutsch here, his idea of hard-to-vary explanations.
Oh, yeah, I love Deutsch. The idea that truth is brittle. You can't just change one little part of a good explanation without the whole thing falling apart.
That's it. A lie is easy to vary. A good explanation isn't. A logical legal system would be hard to vary. You couldn't just tweak it for political reasons because the logic would break.
I mean, it sounds utopian. It sounds incredibly clean. But we have to talk about how you'd actually build this. I'm guessing we're not asking Congress to learn Lodgebon.
No, not next week anyway. The source outlines a kind of Montague-Lodgebon legal stack. It has 4 layers.
Okay, walk us through it.
Layer 3, the top layer, is natural language. That's for us. We still see the law in English.
So it's user-friendly on the surface.
Right. But underneath that, Layer 2 is the Montague translation engine. That's what turns our messy words into rigid logic.
It's a translator.
Then Layer 1 is the formal logic engine. This is the judge. It's a SAT solver that checks the new law against the Constitution's axioms. It runs the proof.
And Layer 0.
Layer 0 is physical reality, the hardware, the reactors, the infrastructure, the code actually touching the metal.
It sounds so perfect. But come on, there has to be a catch.
Well, yeah, there's always a catch. The source is pretty upfront about it.
The oracle problem.
The oracle problem. It's the Achilles heel of all of this, really.
Because the computer lives in its perfect logical box, it doesn't know what's happening in the messy real world unless we tell it.
Exactly. Let's say the law is self-defense is justified if you are in imminent danger. The computer understands that logic perfectly. But who tells the computer that this specific event qualified as imminent danger?
Was the person holding a knife, or were they holding a banana? Were they running at me, or were they running for a bus?
Right. Somebody has to translate that messy reality into the formal language. And that input point, the oracle, that's where human bias can creep right back in.
So we haven't gotten rid of the human element, we've just moved it to the data entry point.
And there's one other big danger the source brings up: rigidity.
Rigidity.
Sometimes the math is perfect, but the result is morally wrong. The classic example is Les Miserables. Jean Valjean steals bread to feed a starving child.
Legally, that's theft, period.
And in a human system, a judge can show mercy. They can use that judicial discretion and say, technically this is theft, but come on.
That's the discretion being a feature, not a bug.
Right. But a computer has no mercy. If a law is mathematically sound, but produces a morally awful result, the computer will execute it faithfully.
It will drive the bus right off the cliff if the GPS tells it to.
Precisely. That's the risk when you take away the magic wand. Sometimes maybe you need a little bit of magic for the truly human situations.
But the core argument of the source is that the trade-off is worth it, that the magic wand does more harm than good on a massive scale.
That's it, that we're better off with a system that is transparent, hard to vary, and formally verified, even with its rigidity, because at least it's honest.
It forces the system to be honest. If a law is bad, you can't interpret your way around it. You have to actually go in, admit the error, and patch the code.
Everyone can see the code.
So where does this all leave us? We started with I before E, and we've ended up with this vision of a correct by construction society.
It's a huge leap, but it's one we have to start thinking about. I mean, we're moving into an age of AI and algorithmic governance. The idea that we can keep running society on these vague, medieval language concepts.
It's like trying to run a quantum computer on Windows 95.
That might be generous. Maybe MS-DOS.
The source ends with this really cool idea of social physics.
Yes, this is the ultimate goal. Imagine a society where justice is as reliable and predictable as gravity. You don't just hope gravity works today. You know it will.
If you drop the apple, it falls. If you break the contract, the consequence happens. No lawyers arguing about the definition of drop.
Exactly. Social physics implies we could design a society where fairness is just, baked into the infrastructure, where the operating system of our lives is verified and bug-free.
It's a wild thought, a world without the magic wand of human bias, just pure, discoverable truth.
It's compelling, and maybe a little scary, but definitely compelling.
Well, that is certainly something to chew on. The next time your phone autocorrects you, just remember that little squiggly red line might one day be the Supreme Court.
Let's just hope it's a bit more accurate by then.
Thanks for listening to this deep dive into coding the law. We'll see you next time.